Hello everyone. So let's talk about today's Geeks for Geeks problem of the day. So the problem statement given to us is very easy. The problem name is a route to leaf path, and the problem difficulty is a medium level, but it's not an actually medium level. It is a very easy problem. Once you read the problem statement, you will understand what you have to do actually in a problem, and uh, after running some example, you'll definitely know what you have to directly do in a problem. So this is not a very hard level problem or medium level. It is a very easiest problem, and you have to just know what is the order you have to follow. Now let's see what is given in a problem statement, and after that we'll just try to apply our intuition in that problem statement. So we have given in binary tree, and you need to find all the possible path from the root node to all the leaf node of the binary tree. What is the meaning of this? You starting from the root node and you are trying to explore the leaf node, and what is the path is coming from the what is the node coming between these two nodes. You have to just insert, or you have to just write that node and return that node list. Okay, so let's see what I am saying actually in the problem statement. So suppose this is the 10 and you have to explore the 40. What is the node coming from the 10 to 40? This is the 20. Okay, now this is the 10 and I have to explain the 30. What is the node between coming 10 to 30? There is no node, so I will explain only 10 and 30. Now this is the 60 and I have to explore the 10 to 60. So what is the node coming from this? The 10, 20 and 60. So this is the another loop. Okay, so this is the basic thing of the problem statement we have given. We have given. So let's start with some example text cases. So suppose this is okay. Now what they mentioned in the next side, there is some node. The path should be written such that the path from the left subtree of any node listed followed by a path from the right subtree. Okay, now what is the meaning of this? So if you are exploring this node, okay, and after some point if you done with exploring this, you come here. Okay, instead of going again to the root node, you have to just explore right node from the here. Okay, so this is completely pre-ordered traversal. You have to just perform a pre-ordered traversal. Just they mentioned a little bit confusion, just make the little bit confusion here, but you have to just do the pre-ordered traversal. Now I have given a hint, you have to do pre-ordered traversal. Now what you will do, you just apply the pre-ordered traversal. So I will go here, I will insert one in my list. Okay, after that I go here, I will insert 2 in my list. After that I go here, I insert the 4 in my list. Then I will go to the left side. Okay, after I go left side, there is no node, so I'll return from here. And after the going right side, there is no node, I'll return from here. Then again I have one list. Okay, then I go here, and after that I just go here and I will insert 5 here. But this is not actually, I need what I need. I just need 1, 10, 4, and then again 1, 2, 4 and 1, 2, 5. So what I will do, I will insert the 4 in my list, and after coming from node, I'll just pop it out. Okay, pop it out means I'll pop this from my vector answer. So storing this, I will use a 2D array. Okay, and I'll just insert this 1, 2, 3 in my answer. Sorry, 1, 2, 4 in my answer. Okay, now again I just coming from back here, means my recursion stack go here, so I'll just pop it out. Now when I am popping, I'll just explain the left node. Okay, when I'm popping, I explain the left node and right node completely. So that after that I just pop the fourth node and I'll go back to the second node. After that I'm just going to the right node, I'll insert this node in my temporary vector. So I'll insert it here. So what it will become 5. Now once it come to the leaf node, just push it out in a 2D answer. So 1, 2, 5, this is a node, and then just go back here by exploring this 2 node. So I am saying if you are on left node, there is no, if this is a leaf node, there is no next node, so I'll just come from here. So while coming from here, I'll just pop it out. Okay, and then after that just you go here. Okay, now once you are going here, you just explore this 2 node as well. Okay, after exploring this 2 node, means left child and right child, if you explore left and right child, just what you are doing, you're just popping that node from the your temporary vector. So now the vector has only 1, and after that you just go to the right side, then you will insert the 3, and this is a leaf node, so you will insert it in the answer. So this is the output for this example. Okay, so there is nothing very hard in this problem. You are using just recursion plus backtracking. Okay, recursion and backtracking. Okay, so this is only this given in a problem statement. You have just recursion you are using for the pre-order traversal, and backtracking for only the making the answer. So let's see the output is correct for this. So let's see 1, 2, 4, 1, 2, 5 and 1, 3. So we achieve the same output. Let's see here 1, 2, 4, 1, 2 and 1, 3. So let's see 1, 2, 4, 1, 2, 5 and 1, 3. So this is all about the problem statement, and I'll just give you the small try run because that it is not a very hard level problem. So let's try to code it out. Okay, so let's see. So I'm just taking a simple vector of vector int, so I'll keep it here, vector of vector integer. Okay, integer answer. Okay, so I will not pass in, you know. Okay, now I'll just take it, and I'll just take vector in temp here on globally. I'm declaring globally. Why? Because I don't want to pass in my function. Okay, now just do a void solve, because I'm not returning it, and just take a node star root. Okay, now I'm doing simply pre-order also. If not equal to root, then return a null. So there is nothing I have to return. So I'll just return. Now if root, there is no root left, not equal to root left, and there is no root node left node. Okay, root right. Okay, so this is then a leaf node. So what you have to do, you have to just answer dot pushback temporary. Okay, then temp dot pop back, because you are coming from the root node, and return. Okay, yeah. So if there is a valid node, you have to just insert that node into temp. Okay, and root dot value, sorry, root dot data. Okay, so nice. Okay, now you have to just go to the root left as a normal pre-order traversal, and you have to just go to the root right. Okay, once you coming from the both node, means left and right node, you will, what you are doing, you are just removing and the temporary vector node value. Okay, yeah. So this is all about the codes, and after that I'll just doing the solve and the root. Okay, so I'll just clear the all this thing, because there isn't some test cases. So I'll just do answer dot clear. Why I'm doing this? Because if there is some test cases, and as I declare this as a global, so it will keep in my answer. So I'll just clear on each time the function is called. Okay, so this is all about the code. So let's try to compile it. If it is get successfully compiled, then we'll try to submit it out. Okay, and if it is get accepted, we'll discuss the time and space complexity of this problem. Okay, so here is some error like a 124 1 2. So the answer is okay. My answer is a completely blank. Why? Because I'm not returning anything. Okay, my bad. Okay, so it passes this test cases, and let's try to submit it out. Okay, if it is get any error in any place, we'll try to fix it out. Okay, so it get accepted successfully. Yeah, so it get accepted. So let's discuss what is the time complexity. We are doing a level order traversal, so it will take a big of n time. Okay, we are using the 2D array for the answer, so we can take it as an extra space, but we are using for the node value. So what is the maximum temporary size? Big of h. Why big of h? Because we are going only depth of the node. Okay, so what will that temp variable will be stored? Either these values. Okay, so what is this height of the tree? So suppose there is a skewed tree, something like this: 1, 2, 3, and 4. This is the maximum height of that tree, and it will store only this node. Okay, so that's why the time will be big of h is the maximum height of the tree. So the space complexity of a big of h and the time complexity of big of n. So this is all about the problem statement. If you have any error or any doubt with the problem, just comment it out, and let's meet tomorrow with a new problem statement. Bye for today.